you very much, Claire, and thank you very much to to Clean Air for inviting me to present a summary of our results. This is a Life Plus project and is focusing on improving air quality in South European urban areas, okay? The cities that we selected are Florence, Porto, Athens, Barcelona, and Milano, and we selected very nice pictures of our cities. We love them, but we want to improve their quality. We are going to criticize them, but in a very constructive way. So the project is led by our organization. We are scientists from the Spanish Research Council in Spain, and our institute is the Institute of Environmental Assessment in Barcelona, and then we have the Institute of Ceramic Technology, the University of Birmingham, the Democritus Center for Air Quality, the University of Florence, University of Aveiro, and the regional air quality stakeholders in the Lombardia region. So the main objective is improving PM levels, okay? Reducing particulate pollution in these 5 cities, although in the last task we are also focusing on ozone and especially on NO2, okay? And then what we want to do is to obtain very detailed source apportionment data for PM10 and PM2.5, and to develop and test and propose specific and non-specific measures to approach the WHO guidelines. Because we have dry environments, for us, raw dust is one of the key components, and then we focus a lot on that. Also the biomass burning, because, as you say, the climate policy is influencing negatively, in this case, on the air quality. Also industrial emissions, and Claire did a very good job in reviewing what is the effectiveness of low emission zone, of eco-labeling of vehicles, of DeNOx technology for vehicles, shipping, biomass burning, and so on. So why we focus on PM10? So you see that we are meeting relatively well the air quality guidelines, but not the WHO, okay? And in our opinion, these 40 and 50 micrograms per cubic meter limit values are too soft. They were planned many years ago, and now we can go further. And then the benzoylfapyrin, for the first time, we never had exceedances, but in the last 2 years, we are starting to record exceedances in rural areas, not in cities. Okay, to do that, then we evaluated what are the trends, because we believe now we have a lot of data and we can learn a lot on interpreting the time series of air quality, and then to evaluate what is the effect of the policy on this time series. And then we documented in B1 the current situation, and then we devised and applied a source apportionment, experimental source apportionment study in the 5 cities, focusing on all these sources, also determining emission factors, experimental emission factors, and chemical profiles of emission factors, and then we tested in real life conditions some of the measures. Okay, and then the last task, the B8, is when Claire and Roy Harrison, they reviewed 10 issues that are very relevant for us on air quality. We will start for the B1, the trends. So you have here the SO2 levels in Spain in the last 14 years, and then you see these are these stations where the coal is used in large proportion for power generation. Okay, we have 22% of coal-induced power generation. But you see that in 2008, the air quality of these remote stations, so it's not depending on where you put the station, these are EMEP stations, decreased, and now these stations are producing energy without increasing the SO2, or at least with the same levels, very low levels. For NO2, as in many other places, you see that in the traffic side, is the top one, there is not a clear decrease or not intensive decrease. This is only 18% decrease in the last 12 years. Okay, now this is a tool you can use, is the NASA SO2 column, and then this is not model, this is not depending on the station, this is measuring the SO2 column. And you see in 2005 how we have here in the north the power plant, here one of the largest power plants in Europe, here using coal, and then it decreased until here where they have very strict regulations with desulfurization, and then you see that since there, levels of SO2 in the atmosphere are very low. So some areas in Southern Europe, you see Greece, you see Sicilia, are similar. They did not change a lot in the last 10 years, but it is not the case of Spain and Portugal. For NO2, this is for us very important. This is also data from NASA that I prepared just for this conference. I plotted, and then you see in 2005, you see Madrid, Barcelona, and in the northwest you see the coal-fired power stations. Okay, so you see how this is decreasing. 2007, 2008, you see, compare 2008 with 2009, and then 2012, and now I printed up to the 12th of October from the beginning. Compare 2015 with 2005. So here there is a mismatch. In the center of the cities, the NO2 is not decreasing, but in a regional scale, ozone episodes exceeding 120 and 180 micrograms and NO2 are decreasing by 60%. This is the financial crisis. Okay? Traffic keeps more or less constant, but on a regional scale, the energy production decreased, and then the NO2 levels at regional scale, not at the urban scale, decreased. For this is, sorry, I forgot to say that in the other part is the effect of SO2 is the large combustion directives, and then this is the effect of the industrial emission directives. You see the top line for PM10. This is, I forgot to tell you that this is the mean value of all stations of Spain, and in the top are the industrial stations, okay? And then you see how in 2006 the mean level of the industrial sites are below the traffic sites. And this is the effect of them, clearly the effect of this directive on industrial emissions. Okay, these are the 5 cities, and you can see how in the last 12, 13, 14 years we had a decrease of the annual PM10 average close to 45% or 50% in the case of Porto and Barcelona, and around 34, 32% in the other cities. And then we had chemical speciation for PM10 in Barcelona from many years ago, and then we are continuously doing source apportionment. And then we evaluated also the effect, the trends in the last 12 years, and then we see clearly how the traffic contribution to PM10 did not increase very much. The mineral dust You see this hump in the middle, close to 2008. This is due to specifically to the construction of a new subway line, causing a lot of problems with mineral pollution. Then we have the sulfate, the nitrate, the industrial emissions, and so on, all decreasing, very clearly decreasing, not because the financial crisis. Before the financial crisis, it was decreasing, with the exception of the sea salt. Sea salt is not decreasing. This is a good result, otherwise will be not meaningful, okay? And when we apply this to PM1, because we do chemistry also of PM1, then the decreasing trend is much clearer. So the elemental carbon that when we started measuring in 1999, the mean value was around 5 micrograms, now is 1.2. So the effect of the filter traps is very clear. Not so clear in PM10, because now 40% is non-exhaust emission and is affecting PM10, but very clear in PM1. This is also relevant. Arsenic, when we started in 2001, and how is decreasing. Manganese, highly decreasing. Vanadium, in 2008, the air quality plan is not allowing anymore to obtain power generation from petroleum coke or fuel oil, only natural gas around Barcelona. So look at this, this is summer, and now we are only having the effect of the harbor. Our vanadium is only supplied by shipping emissions, compared with this, where power generation was allowed for using petroleum coke, for example, okay? And the tin is coming from the brake pads, and as you see, this not changed a lot, because no directives apply to the non-exhaust emission, okay? In your case, you have a lot of rain, and then you are moisturing the surface of the road, and you don't have resuspension. For us, we have very intensive resuspension, okay? So we did the source apportionment study. We collected 2,200 samples, and then in these 5 cities, by coincidence, all of them have in the picture a football course. I don't know what is the reason. And then the first result that we want to show and to assess to the stakeholders is the relevance of the secondary PM, okay? With the exception of Porto, where we had a traffic station, primary PM constitutes only 62%, or not only, a lot, 62%. And secondary particulate matter, organic and inorganic, 38. But look at this, in all the other cities, the range is very narrow, only from 30 to 35%. Very different cities, but the primary contribution is only applying to 30 to 35% of the PM 2.5 levels. So 65% is secondary. So the main focus, also primary PM 2.5 of course, but focus on gaseous precursors will be more efficient than only PM, primary PM. In the suburban areas, the proportion reaches 82%. It's like in the remote places or in the rural sites, you can have 85 up to 90% of secondary origin. Okay, these are the results, very complex to explain in very short time, but during the exceedance days, we had still 35 to 45% is from road traffic, but very important, 20 to 30% are non-exhaust emissions. So it's not enough, these zero emissions that you listen talking about electric cars is not true, not zero emissions. Non-exhaust emissions are still relevant. And then biomass burning, it's very relevant. We have very high proportion, 25 to 30% of the PM 2.5 composition is due to the biomass burning in Athens, in Porto, in Florence, in Milano, not in Barcelona. We will see why. In Barcelona is negligible. And also anthropogenic dust accounts from 10 to 30%. This is the lack of rain, the resuspension, okay, and the impact on air quality. This is similar values, less dust in PM 2.5, but also biomass burning. You can see 25 to 33% of PM 2.5. This is clearly the effect of the biomass burning. This is 1 year. Daily values of levoglucosan is the tracer of biomass burning in Milano, in Porto, in Florence, in Athens, and in Barcelona. You see that there is not effect. 98% of the domestic heating is natural gas. We have 180 years of the company providing natural gas, and then it's a clear effect on reducing this contribution. Okay, we studied the biomass burning to propose protocols to reduce the emissions. In another task coordinated by the University of Aveiro, we selected all the Mediterranean biomass or agrofuels or wood, pellets, and also some residues like olive pit, shell of pine nuts or almond shells that are used in many places. And then we selected these 4 types of appliances. This is an Austrian eco-label boiler, and this is a pellet stove. This is important to say that in the case of the pellets, we selected most of the pellets that we found. And then only one was certified N+, okay? And the others are sold commercially, but without certification, okay? Then these are the results. In a fireplace, conventional fireplace, compared to the pellet stove, we have a factor of 15 of emissions. But this is important. Only the pellet with N+ met the most stringent regulations that are available in Germany, are in Austria, 25 milligrams per megajoule. This can be only met using this certified EN+. The other pellets, as you see, are exceeding these values. And the most striking finding was that the pellets contain up to 5% of lead in the ash. Because with the exception of the N+, the other probably contained recycled industrial wood from the furniture industry. And then this is not biomass, but it is considered, even in the medium scale combustion directive, they did not stop this type of fuels. And you can burn it in the combustion, not in the incineration directive as it should be done. But it is not only lead, it is zinc, it is iron, and especially arsenic. 75% of the arsenic in the world is consumed by the wood treatment industry. Okay, so we need not only to certify the appliances, but also the origin of the wood used for pellets and so on. We obtained these emission factors and chemical composition. We have many reports. If you burn one type of wood, what organic components, what metals, everything we have. With benzoylfapyrin, we compare the benzoylfapyrin from pellet 1 with all the other biofuels, and you can find this in the report. I will give you the website if you like. Another task was focusing on road dust. This instrument we patented recently, and then it is, we call it the dock because it's like a dock. And then it's like a vacuum cleaner with a PM10 inlet or a PM 2.5 inlet. So we go to the road, we stop the police, and we clean with the police. They stop the traffic for us. we clean 1 square meter, and then we suck the PM10 which is available for resuspending. So we did studies for the city council of Paris, of Milano, many places in Utrecht, also in Switzerland, in Zurich. And then as you see, the road dust load, in the case of this is PM10, can reach 20 milligrams per square meter in Southern Europe, okay? And this is important. Then the composition is very different. This is the study we did for Utrecht and from Zurich, and the mineral matter in Spain is very large and here is very low. The levels in Utrecht, the total levels are lower, but in this case we have a lot of brake pad products and tire products. In this case, in addition, we have the mineral dust from public works, from accumulation of pavement erosion, and so on, even from African dust. So what we applied in real condition is the CMA, the magnesium chloride, the water flushing in 2 kilometers, one street of 2 kilometers in Barcelona. Also in the industrial roads in the ceramic area, and also in unpaved roads to try to see what is the effect in public works, for example, public construction works, okay? And then finally, we have many parks like this, sandy playgrounds, and then we also apply polymers here to avoid the resuspension, okay? We have the reports also with detail, but I will tell you only that CMA didn't work in any of the cases. And we tested everywhere, because with the high insulation that we have, it is dried in a few hours and then the effect is disappearing. CMA is working if you have a lot of humidity in there, and then it keeps the glue with the particles. But if you dry, if there is a very dry environment, it is not working. Okay, for the street washing, we obtain very good results if you do that just 3 hours before the rush hour, because you are not cleaning, taking out the particles of the surface, but you are only moisturizing the surface. If you do it during the night, at 12 in the night, at 7 o'clock in the morning, the effect will be very low, okay? And the nanopolymers were working very well. We reduced monthly 3 micrograms of PM10 in an area with a lot of sandy parks. The last one of my slides is this one. I am not going in because this is the Claire presented yesterday, the very good report she did on low emission zones. And these are all the Claire's reports. Especially, I like the one on NOx reduction technologies that includes the results of Dr. Tate from Leeds, and many other. The ultra-low SCRT devices on the buses for public transport. Also, the evaluation of why the Netherlands, and especially Norway, have 5.8 and 5.4% electric vehicles in the fleet, whereas most of Europe has 0.2%, and then it is because they have not VAT excluded from VAT, from the matriculation, from the tax. The taxes are very low, so low that they reduced. It is only 1,000 euros more expensive than a petrol car. If you take into account all the cycle of the life, you can drive in the bus line and so on. So there are many advantages given since 1990 in Norway, and that's the result. So we evaluate all of these effects, especially for the stakeholders, to have a summary for every one of these topics. And we would like also, in fact, she has finished already, this last, for us is very important, how we can solve the interference problems between climate and air quality policy. So thank you very much for your attention, and if you like to see the reports, in this website, you can find all the reports that, all the results that I mentioned here. Thank you very much.
I was wondering, what is the nanopolymer you're adding to suppress the dust? Because it seems kind of strange to add something new to a mixture. And I always get concerned about nanomaterials which are being added to the environment. And how much do you know about the toxicity? Because it's a quick solution. So what exactly is that compound which is being used?
It is not a dangerous one. It is obviously is a secret for the company, but they give the non-toxic certificate. But we are not using that. In fact, the idea is to reconvert the sandy parts, okay? Not to use that. We tested because they are available in the market, but we are not using that.